Hello. Welcome back. This is just a video summary of our last lesson on how you can calculate rate of reaction from a graph and how you can use the graph to draw, or you can to draw a line of best fit given the different points. You know, in the last lesson, we discussed on how you can calculate the rate of reaction. Many students face problems when it comes to calculating the rate of reaction, the rate of a chemical reaction. As we earlier said, the rate of a reaction is a change in the concentration of the product with time. A change in the concentration of the reactant or the product with time. Now you could be given a curve like this one. You could be given a curve like this to calculate the rate of a reaction. Take for instance, you have a curve like this one. This is a reactant curve. As time progresses, the curve slopes from left to right. The concentration of the reactant is decreasing with time. There is another curve like this. In a reaction, for example, in a reaction between calcium carbonate and hydrochloric acid to produce calcium chloride, water, and carbon dioxide. In measuring the amount of carbon dioxide that is being produced, and you collected your data after a period of time, and you're now plotting the concentration of the concentration against time, you will see that the curve for the product, which is carbon dioxide, will definitely increase from left to right, indicating that as time progresses, the concentration is increasing since more of the marble chips are being converted to the carbon dioxide. If we join these two curves, this is what we are going to have. Concentration against time. But you could be asked, our question today is, how can you calculate the rate of reaction from a data like this, a curve like this one, either for the product or for the reactant? Let me say it's 100 seconds. You are asked to calculate the curve, the rate of reaction at time 100 seconds. That's the place. For the product, you are asked to calculate the rate of a reaction at time 100 seconds for the reactant. This is the point. For the product, in order to calculate the rate here, you need to find a gradient. And in trying to find a gradient, you need to draw a tangent at the particular place, the particular spot, 100 seconds. You draw a tangent here, then you find a change in the concentration of the product, here, all over time. If you were to draw it here, you would draw a tangent here at a particular spot here and check for the change in the concentration of the reactant with time. There are more examples that can lead us to this. This is a proper example for you to better understand. Take, for instance, we have this. This is an example. In calculating this, if we draw, for the gradient, we draw a tangent at a particular spot here, then we will look the corresponding on the concentration on the y-axis, the concentration of the reactant, a change in the concentration of the reactant, and a change in time, and then we will have our gradient, or we'll have our rate. This is an example here too with this. And another example which can make you to better understand this is this one. This is a curve, and we are told, let me say at 3 seconds, you are asked to find the rate of the reaction. If we draw a tangent here, we measure it here, the change in the concentration here will be from, let me say, 0 to 20, 0 to 18 seconds. Sorry, 0 to 18. Let's say that's a concentration. Now, you look at the time, the time difference between 1.5 here and 4.5. Let's say from 0 to 18 is the difference is 18 minus 0, which will give us 18. Then the change in time will be 4.5 minus 1.5, it will give us 3. And if we say a change in Y in the concentration divided by a change in X, which is the time, it will be 18 divided by 3, which will be 6. Well, it will definitely be 6. It could be 6 gram per second, or it could be 6 cm cube per second, depending what we are measuring. So these are examples that you can use this. These are more other examples. Now, we can still use this when we have a curve like this one. We can use that when we draw a curve like this. Then from there, we can now find our rate. And the units are also very, very important. Take for instance, we have this. Let's have this for instance, an example like this in calculating the rate. You are given how can the rate of a reaction be calculated from the graph like this one. Now, let's say it is a particular time. Okay, it will be a change in Y, that's the concentration. It's a reaction between hydrogen being produced and hydrogen being produced with time. We can go further, and we can go further in another example like this other one. Let's say we have a time here. You are asked to look for the concentration at a particular point on the curve. You need to draw your tangent. That's how you start drawing the tangent. Secondly, you now have to look for the change in the concentration of the hydrogen produced and the change in the time, that is X. A change in Y all over change in time. A change in Y all over change in X, which is time. Okay, this change, if we calculate it from there, it will definitely be from 45 to 62, and the change will be 62 minus 45. Then if we calculate the change here, it will be 18 about to 28. So it will be 28 minus 18, the difference. And what will be the difference? It will be 170 cm cube per second. That will be our gradient, or that will be our rate of the reaction of this reaction. So this is how you can calculate the rate of reaction. Now, given the rate of reaction or given a data to draw, given a data or a graph to draw a line of best fit, which is always being asked in your exam, what is the next thing you do when it comes to that? The first thing you do in trying to draw a line of best fit, what is a line of best fit? That's the first thing. What is a line of best fit? Most students do not usually understand what is a line of best fit, but I want you to understand here that a line of best fit is a straight line on a scattered plot showing how the number of points above the line are almost equal or equal to the number of points below the straight line. There is something that must be noticed in drawing a line of best fit. In drawing a line of best fit, you must know that at times the line may pass through all the points. In that case, that is a straight line graph. At times, it may pass through only a few of the points, and at times it may not even pass through the points. I want to show an example of it. You are given points like this to draw a line of best fit. These are the points that must have been got from maybe an investigation. Now we want to draw a line of best fit here. We need to draw a line that may pass through 1, 2, or 3 of the points. The first thing is you have to take into consideration the number of points that are here. Then you try to see how you can draw a line that the points above the line and the points below the line are almost the same. It might be the same at times, it might not be the same. So this is how you do it. After taking into consideration the number of points, you can draw a line like this one. You will see that below this line is passing through only one line, only one spot. And below the line, how many points are there? We have 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you see that below the line, we have 1, 2, 3, 4, 5, 6, 7, 8. Above the line, we have 1, 2, 3, 4, 5, 6, 7, 8. And only one line is passing through one line. So this is a good line of best fit. Another example could be this other one. Look at the line, look at the points here. Look at the points here. You will see that the points here are being choked up. First thing is how many points are here. You have to take it into consideration. Then, in trying to draw a line of best fit, try to see how the line can link up with the lines, the points below the point, below the straight line. It's a straight line. Secondly, check the points below the straight line, whether they are equal to the point above or almost equal. That will give you the line of best fit. This is how it is being drawn. You check equally here, you will see that there are 1, 2, 3, 4, 5, 6, 7. And below you will see there is 1, 2, 3, 4, 5, 6, 7, 6, 7. And the point is passing through 2 points. So the points, I said, it might be passing through some points. At times, it may not pass through some points. But make sure the points above and the points below are the same. Secondly, there's another example here, the same thing. You might have a curve. In this case, we take into consideration what? It's a solubility curve. We take into consideration the number of points involved first. We have 1, 2, 3, 4. There are 4 points involved there. In this case, in order to draw a line of best fit, I said the line of best fit is a straight line. The number of points above the straight line must be equal to, it might be equal to the number of points below. At times, they may not be the same. The straight line could be passing through on some points. At times, it may not pass through some points. At times, it may pass through just a few points. In this case here, it is not passing through any point. But what has happened? We draw a straight line here. There is a straight line here. This is a line of best fit, which is the straight line. And this straight line, the number of points above the straight lines are 1 and 2. And the number of points below the straight line are 1 and 2. You see that this is the line of best fit. So the same thing, you could be given a point like this one to draw a line of best fit here. It's the same thing. How many points are there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 points. We need to draw a line, that a straight line, that the points above and the points below might be the same or might not be the same. It might be the same, but make sure that it must equate. Okay, we might decide to take the points here. If we decide to take these 3 points here, we decide to draw a line of best fit using these points here, the 3 points, the first 3 points. 1, 2, 3. The line will come straight here. The line will come straight here and go straight here. You will see that the points here, 1, 2, 3 will be above, and the points here, 1, 2, 3 will be below. But we are using 3 points. So the line of best fit is this one here, involving only these 3. 1, 2, 3, and it goes straight, and that is the line of best fit. At times, it may be passing through some points. At times, it might not pass through some points. You could be given a curve like this other one again to draw a line of best fit. It's the same procedure. It's the same procedure. We might decide to use two of them. If we use 2 of them like this and this other one, you will see that if we use this 1 and 2, you will see that the points above and the point below will be the same. That is the strategy in it. You must know the number of points that are there before drawing a line of best fit. So a recap is that it is very, very important to calculate the rate of reaction by drawing a tangent at a particular spot. If you are given a curve to draw the rate of reaction, if it is for a curve involving the reactant, you need to draw a tangent on a particular spot given the time given the time on the curve or on the graph. You need to draw a tangent there and then calculate the change in the concentration divided by the change in time, and you have your rate of reaction. The units are very, very important. The units are very, very important. If the concentration is we are dealing with a volume, it will be a volume with time. It could be cm cube, it could be dm cube with cm cube per second. We are dealing with gram, it should be gram per minute or gram per second, depending on what you are measuring. So you are also have to draw a gradient to calculate the rate of a reaction for a product curve. You also have to draw a tangent. You need, in order to have draw a tangent, it must be a straight line, then measure the change in the concentration of the product divided by the change in the in time. Then you have your rate, but the units are also very, very important. Then you can still draw, again, to draw a line of best fit on a curve that is given the points. You must make sure that it's a straight line. A line of best fit is a straight line that might pass through some points. It might not pass through some points, but make sure that the number of points above the straight line must be equal to, might be equal to the number of points below. So that is very, very important. You must first of all take into consideration the number of points, then try to draw a straight line in between them. It could be a straight line where it could be a straight line graph where all the points will be, the curve will pass through all the points. At times, it will not be a straight line graph. It could be a curve that some points above will be equal to the points below. So these are very, very important in calculating the rate of reaction and in drawing a line of best fit given the data. Thank you very much. Bye-bye.